Alright guys, you should have a clean piece of notebook paper, get your notes titled and dated. This is going to be part 1 or video 1 of 2 videos. So this is the video talking about applying more than one exponent property. And I know that we have done a few problems where we've had to do the product rule and then we've had to do the quotient rule to start combining. So we've kind of started touching on these a little bit, but some of these could potentially have up to all 5 of the exponent properties. So real quickly, just like when we were solving equations, we had a particular order that we did things. We distributed and then we combined on the same side. Then we moved the variables to the same side of the equation, and then we solved the equation. Okay, so just like that, we're going to have a particular order that we should always complete things, complete the exponent properties if they are in the problem. Okay, so that's the first thing that we're going to talk about. Okay, so the first exponent rule that you should always take care of if it is in the problem is the power to a power. This is really similar to to the distributive property where we get rid of the exponents. Remember, power to power is when we multiply the exponent on the outside times all exponents on the inside. The second rule that you're going to want to take care of is the product rule. And that's if they have the same base and they are being multiplied. And then we add the exponents. The third one then, and you can pause this at any time if you need to. The third one then is the quotient rule. That's if they have the same base and they are being divided. Then we subtract. And then the fourth one that you're going to take care of is the 0 power. Anything to the 0 power equals 1. And then, of course, the last one is the negative power, and we have to flip / move it to make it positive. So this is the order that we are going to complete these exponent rules as we work our way through these problems. Okay, you're going to need to pause this if you need to finish or go back and listen to any part of this, because I'm going to go ahead and start going through some examples. You have to have all that written down in your notes. I won't sign off if that's not all there, okay? So we're going to do a few examples together. Okay, so the first thing that I noticed is that this has parentheses, okay, which probably means that the power to a power rule is going to be involved, okay? So I'm going to have to use the power to a power rule to multiply and get rid of those parentheses and distribute that exponent. Guys, you have to show up your work. So I'm going to take 3 to the second times 3. 4 to the 4th times 3, and 4 to the 6th times 3. So I get 3 to the 6th times 4 to the 12th over 4 to the 18th. Okay? So the parentheses are gone. The next rule that we go to is the product rule. Well, the product rule says that anything with the same base that's being multiplied. Well, the only multiplication in this problem is right here. And that has a base of 3 and a base of 4. So those don't have the same bases, so I'm not going to be able to combine them. So the product rule is not in this problem. Okay? So let's move to the quotient rule. And I'm going to go ahead and rewrite that. The quotient rule says that if they are being divided, guys, remember this fraction bar means division, so this is a division problem. So if they're being divided and they have the same base, so these 4s have the same base, then we are going to combine them by subtraction. Remember, I've always said that if you take the largest minus the smallest, that's easier. You don't have to do that, but it's going to be more work if you don't. So I'm going to cross this off because now it's down here at the bottom. So I got 3 to the 6th on the top, and then 18 minus 12 is 6. So then the next one is the 0 power. Well, there's not a 0 power. Those both are 6s. And then the next one is the negative. Well, these both have positive exponents, so that means this is as simplified as I can get it. So that would be our final answer. So there were 2 exponent rules involved in that problem. All right, let's do another one. Okay, so the first thing I notice is that there's 2 different sets of parentheses, okay? So I'm going to have to distribute the 3 on this first set of parentheses, but on this second set of parentheses, I need to distribute the 5, okay? So I'm going to distribute it to the 4, but then this 7 doesn't have an exponent. Guys, you can't forget to give it an exponent, otherwise you're going to be completely wrong. So we're going to take 6, 2 times 3, 7 to the 4th times 3, and then that's one big multiplication problem, and then 6 to the 4th times 5 times 7 to the 1st times 5. So I get 6 to the 6th times 7 to the 12th times 6 to the 20th times 7 to the 5th. Okay, so the next one is going to be the product rule. Well, the product rule says that if the same bases are being multiplied. Guys, this is one big multiplication problem. There is not division in this problem at all. Okay, so we are going to, they're all being multiplied, so if they have the same bases, so the 6 plus the 20 times the bases of 7, so 12 plus 5. Remember, with multiplication, numbers get bigger, and so does adding. It's one way to remember it. So we get 6 to the 26th times 7 to the 17th. There's not a 0 power, there's no negatives, so we are done. All right, if you want, I would maybe pause the video on this next one and see if you can't figure out what you're supposed to do. Remember, go in that order that we put on the first slide. All All right, so the first thing I notice is that these all have the same base, and there's no parentheses. So that means the power to a power rule isn't going to be in this problem, okay? Now, guys, you have to remember that you have to take care of the product rule and the quotient rules separately. So you won't ever just combine everything on the top and the bottom all at the same time, okay? You have to combine on the same side first. So you're always going to need to keep these separate in your first step. And guys, the product rule is first, which means if they're being multiplied and only these bottom two 8s are being multiplied and they have the same base, can we add? So we're going to keep the base the same, take -2 plus 7, and bring over the -5 over here. Okay, so we get 8 to the 5th and 8 to the -5th. Okay, so now we have the quotient rule where if they're being divided and they have the same base, we're going to subtract the exponents. Okay, so since this one's larger on the bottom, I'm going to take 5 minus the -5. Guys, notice my math problem is now on the bottom of my fraction bar. So I get 8 to the 10th, and since there's nothing on the top now, I have to hold it with a placeholder of 1. Remember, guys, if the 1 is on the top, you cannot just take it away, okay? There's no negatives and there's no 0 power, so we're done with this problem. All right, we'll do one more in this first video. All right. First thing I always notice is whether or not they have parentheses, and this one does, so that means I have to get rid of that first. Multiply the exponent, so I have 3, 2 times 2, times 4, 5 times 2. And I'm going to bring everything else down. So I get 3 to the 4th times 4 to the 10th times 4 to the -8 times 3 to the -10. Guys, this is one big multiplication problem, so that means it's the product rule. So we have to add our like bases. So we're going to take 3 to the 4th plus -10 times 4 to the 10th plus -8. So we get 3 to the -6 times 4 to the 2nd. Okay. There's no quotient property because there's no division in this problem. Okay. But there is a negative exponent. Okay. So since this isn't a fraction right now, in order to be able to know where to flip it to, I need to make it a fraction. Remember, we only move them if they're negatives. So 3 to the -6, since it's on top right now, it needs to go to the bottom to become positive. And then 4 to the 2nd, since it's already positive, it's going to stay on the top. So that this is my final answer. Alright, that's going to be the end of the first video. If you need to go back and watch any part of that, please do so, because this is going to be pretty difficult, okay? And your worksheet's going to be pretty tough this time, so you need to know what you're doing.